Adjunct Professor Moran, Microeconomics 112. In this video we're going to review a concept and introduce another concept. We're going to follow this video with a final problem that takes us through the entire comparative advantage process and actually proves out gains from trade. Determine comparative advantage. Nations trade on the basis of comparative advantage, as do individuals. But how do we determine who has comparative advantage? To do this, we need to calculate each country or person's opportunity costs for both activities. That's what we did when we calculated we started with an input table and worked all the way through to output table and comparative advantage. We started with an input table, we converted it to an output table, and converted the output table to an opportunity cost table so we could find comparative advantage. The way we calculate opportunity cost depends crucially on how the product data are expressed. What they mean is it an input table or an output table? There are two ways to measure productivity. We can calculate output over a given period of time. That's output divided by input. In this example, the input is time. Or we can measure the amount of inputs, usually time, could be acres, gas, anything like that, necessary to do an activity. Examples of output are tons per acre, miles per gallon, words per minute, apples per tree, televisions produced. Examples of input are number of hours to do a job, gallons of paint to paint a room, number of acres to produce feed, and number of pitches to throw a strike. We're going to work through two examples that measure productivity differently, one an output, one an input. This is what an output table looks like. Tons of fish produced per hour, where fish is what we want, so that's an output, and they're per hour. Use the per sign as a division sign. So it's fish per hour. So you should be able to recognize that as an output table. So any number without a denominator has a denominator of 1. So that's 60 per 1, 45 per 1, 25 per 1, and 40 per 1. This is fish per hour, fish per hour for Nancy, and this is cheese per hour. Two very stinky products, fish and cheese per hour. So Ted can produce 60 tons of fish in an hour. Nancy can produce 45 tons of fish in an hour. An output table, and Ted has an absolute advantage in terms of making fish. When it comes to cheese, Ted can produce 25 tons of cheese in an hour. Nancy can produce 40 tons of cheese in an hour. 40 is larger than 25, so Nancy has the absolute advantage in terms of producing cheese. Let's look at input table. This handout is not posted online, so these are just notes. Acres required to produce apples or pears. We want apples and pears, that's the good, but this is acres per fruit. Any number without a denominator has a denominator of 1, so that's 5 over 1, 6 over 1, 2 over 1, and 3 over 1. So that's acres per bushel of fruit. Acres per fruit. Acres per fruit. Acres per fruit. So we would like to convert that to an output table. To do that, you just take the inverse. If this is input per output and we want output per input, just flip the ratios. So Tony can produce 1 bushel of fruit in 5 acres, and Chris can produce 1 ton of fruit in 6 acres. Tony has an absolute advantage in producing apples. Pears, Tony can produce 1 ton of apples. Apples, pears. Tony can produce 1 ton of pears on 2 acres, and Chris can produce 1 ton of pears on 3 acres. So Tony is better at he has an absolute advantage in both apples and pears. But Tony will not be making both apples and pears, because trade is not based on absolute advantage, it's based on comparative advantage. Here's a new idea. If you're looking at an output table and you want absolute advantage, you pick the larger number, 1/5 compared to 1/6, or 1/2 compared to 1/3. If you want to determine absolute advantage from an input table, you pick the smallest number. Which person can produce a result with the smallest amount of resources? Input table, absolute advantage. So Tony takes 5 acres to produce 1 bushel of apples, and Chris takes 6 acres to produce 1 bushel. So Tony uses less input or resources to produce an output. He's got the absolute advantage. When it comes to pears, Tony can produce, with 2 acres, 1 ton of fruit, but Chris needs 3 acres to produce 1 ton of fruit. So Tony can produce the fruit with less resources. He's got the absolute advantage. So you pick the smallest number from an input table, but the largest number from an output table, in order to determine absolute advantage. So that's a review of what we've been doing so far. Now, we're going to do another problem. Some of it's going to be practice, but we're going to introduce a concept called gains from trade. The following comparative advantage problems illustrate how two nations, individuals for microeconomics, can trade even if one is more efficient at producing both products. We did it in a prior video where Hannah was better at cleaning offices and jail cells. She had the opposite advantage in both, but she was going to be cleaning offices and Andy was going to be cleaning cells, because trade is not based on absolute advantage, it's based on comparative advantage. The country that is more efficient in the production of a good is the country that can produce the good with the least input. In other words, if the United States can produce a ton of oats in 3 hours and Scotland can produce a ton of oats in 4 hours, the United States is more efficient in the production of oats. In the language of economics, the United States would have an absolute advantage in the production of oats. But a nation has a comparative, or individual has a comparative advantage in the goods in which it has the lower opportunity cost. If you make one thing, how much of the other do you not make? Opportunity cost. The nation should specialize in the good for which it has the lower opportunity cost and trade for the good for which the other country has lower opportunity cost. A nation with an absolute advantage in the production of both goods will have a comparative advantage in the production of only one of these goods. So although a nation can have the absolute advantage in both goods, it can only have the comparative advantage in one good. New concept. Terms of trade is the exchange rate between two communities. For example, 2 bananas for 30 grapes. Gains from trade are the additional amount of commodities a country has after specialization and trade in comparison to the combination before specialization. For example, a country may gain 5 bananas relative to the amount of bananas it had when they produced both, using only their own resources. So, up till now, we've been discussing trade, and we've been just saying that a country will not be a country will not produce all the goods it needs. A country will specialize in the production of one good for which it has an abundance of resources, not produce the other good. Another country will have a different amount of resources and specialize in the other good. Each country will produce so much of a surplus that they will be able to trade for the good they have not produced and end up with more of both goods. And that's the concept that we're going to use a numerical problem to demonstrate next.